This is our video lesson for Unit 6, Lesson 6, and we are halfway through this unit. This is the last lesson before your quiz. Here's a list of all the things you'll need. So pause the video and grab all those supplies so that you've got everything ready to go. And this video is going to incorporate some guided practice. So we'll talk a little bit about that as you're working through it. But this is kind of where we're bringing everything that we've done together. So here's our work with exponents, okay? To review our exponent properties, to start, if you have x to the a times x to the b, so if you are multiplying with the same base, you can add your exponents. So multiplication, same base, one term. That's important. There's no addition or subtraction in there. So you can add your exponents. Power to a power. Again, it's a monomial, a single term. You can multiply your exponents, a times b. And if you're dividing, again, a monomial by a monomial, you can subtract your exponents. And remember, we've got to subtract them top minus bottom. So a minus b. If then you end up with a negative exponent, you've got to move it. Okay? So let's take a look at all of these. We are simplifying. So anytime you're asked to simplify a giant fraction, simplify the numerator first, then the denominator. So if I look at my numerator, I'm multiplying, which means I add my exponents. You can also picture it as you've got 5 x's multiplied together times 3 more x's. So altogether, that would be x to the 8th over x to the 12th. So now to simplify this, I now have division, which means I'm going to keep my base the same and I'm going to subtract my exponents. 8 minus 12, which would give me x to the negative 4. And remember, we want n. It says n could be either a positive or a negative integer. So you can stop here, x to the n, x to the negative 4, or you could rewrite it as 1 over x to the 4th. Okay, I would accept either of those. This is more correct based on the directions because they want it written as x to a power. Okay. Part B, I'm multiplying, but before I multiply, I better figure out what each of these factors is. So I've got a power to a power, which means I'm going to multiply my exponents. So this becomes x to the negative 12 times, here's another power to a power, x to the 15th. So now that I've simplified each factor, I look at what I've got. I've got x to the negative 12 times x to the 15th. I'm multiplying, so I can add those exponents, negative 12 plus 15, and that's going to give me x to the 3rd. Okay, next one. This is another giant fraction. So again, I've got to simplify my numerator first. My numerator is a power to a power, so it's multiplying. So it's x to the 6th. My denominator, I'm multiplying, so I'm going to add those exponents. So it'd be x to the negative 4. Now when I look at what I have division, which means same base. So it's going to be x to the top 6 minus the bottom, which is negative 4. So in my calculator, I'm going to write 6 minus negative 4 because I need to subtract those. Even if the bottom's negative, I still have to put subtraction in between them, and I get 10. So this simplifies to x to the 10th power. Okay, so again, it's not something you're going to be able to do really quickly. Take your time, think about what your rules are. Now, we want to be able to work with negative exponents. So, oh, hold on. Oh, that's fine. Thank you. Okay. Okay, that was just a quick somebody at the door. Okay, so moving right along. Write each of the following expressions involving negative exponents as fractions. And we're going to try to avoid using our calculator. So if I've got 2 to the negative 1, remember a negative exponent means I'm doing 1 over 2 to the first. 4 to the negative 3 means 1 over 4 to the third. Take a minute and try C and D, and then press play to check your work. So C should be 1 over 3 to the fourth, and D should be 1 over 6 squared. Okay, so just a quick reminder of what negative exponents mean. They mean 1 over that base to a power. It's also important to be able to write unit fractions as whole numbers. Hold on, I have to sneeze. Excuse me. Excuse me. Now, there's a word we're not familiar with, a unit fraction. A unit fraction means 1 over a number. Not super critical that you know that, but still, we should be able to go backwards with this, okay? So we want to write it as a whole number raised to a negative power. So let's start by thinking about what 1 over 9 is equal to. Remember, we're always rewriting things. So can I write 9 as something to a power? Let's see. Let's break 9 down. 9 is 3 times 3, so it looks like it would be written as 3 squared. Since 3 squared is in the denominator, I know that it must have had a negative exponent to start with, so I can rewrite this as 3 to the negative 2 power. Okay, let's look at 1 over 5. Can 5 be broken down? Well, 5 can only be written as 5 times 1, so it can't. So the only way I can rewrite this is 1 over 5 to the first power. Since 5 to the first is in the denominator, it must have been a negative exponent. So 5 to the negative 1. Okay, let's break down 1,000. So 1,000 is going to be 100 times 10. 100 is 10 times 10. Okay, I'm not going to break those down any further because it says make the base as small as possible. I think the only way I can write 1,000 as a number to a power is 1 over 10 to the third. And then since 10 to the third is in the bottom, that must be 10 to the negative 3. Okay, pause the video and try D, and then click play to see how you did. So for 16, I can break this down into 4 times 4, but 4 is 2 times 2. So I can actually write this either 16 could be written as 4 squared, or 16 could be written as 2 to the fourth power. They say make the base as small as possible. So my smallest base would be here with 2. So I'm going to write this as 1 over 2 to the fourth. And that would become 2 to the negative 4. The other way you could write it that would be acceptable would be 4 to the negative 2. You just wouldn't be using the smallest base possible. Next thing, they want us to justify why this is equal to 3 to the x plus 5. So we are multiplying, okay? The base of this guy is 3. So what I'd like to do is I'd like to rewrite 1 over 27 using a base of 3. So I'm going to break down 27 and see if I can write it as a number to a power. 27 is 3 times 9, and 9 is 3. So I could rewrite 1 over 27 as 1 over 3 to the third. And then remember we said if you have a unit fraction, 1 over something, you can rewrite that with a negative exponent. That would be 3 to the negative third. So this product here can be rewritten as 3 to the negative third times 3 to the x plus 8. So now I've got common bases. I'm multiplying so I can add my exponents. So this would be 3 to the negative 3 plus x plus 8. Negative 3 and 8 gives me 5. So we've just shown algebraically that we can turn this product into 3 to the x plus 5 power by rewriting 1 over 27 in an equivalent form using a negative exponent. Okay, so now we're going to take a look at exponential functions, okay? And we want to be able to rewrite them in different forms. So let's take a look at the directions. It says rewrite each of the following so that they contain a single exponential expression. So 5 to the x plus 3 times 5 to the 2x minus 1. I can add those exponents. So that would be 5 to the x plus 3 plus 2x minus 1. So that would be 3x plus 2. Next one, part B. I've got a power to a power. So it would be 10 to the 2 times 2x minus 3. So I'm going to distribute that 2 through, and it'll become 4x minus 6. So 10 to the 4x minus 6. Part C. Think to yourself for a minute, what will you be doing with these exponents if we're dividing? Hopefully you recognize that we're going to need to subtract them. So my base is going to stay 2. My first term, the thing that goes first, is 6n plus 5. But then I have to subtract from it the entire second exponent. Those parentheses are critical. You must include them because this is a negative 1 out front, which means I need to negate both of those. So it's going to be 2 to the 6n plus 5 minus 4n minus 1. And now I can combine my like terms. 6n minus 4n is 2n. 5 minus 1 is 4. And then part D, I've got 7 to a power over 7 to a power that's also being cubed. So since I'm cubing the whole thing, I can break this down and say, okay, that means I've got 7 to the 2x cubed over 7 to the x minus 5 cubed. When you cube a whole fraction, you can rewrite it as cubing the top over cubing the bottom. So I need to multiply these. So that's going to be 7 to the 6x. And then I need to multiply these, but there's more than one term. So I'm going to have to distribute. So it'll be 3x minus 15. I'm not done though, because now I have division here. So what can I do with these exponents? Well, I can subtract them. So it's going to be 7 to the 6x minus, and I need to make sure I'm subtracting this entire quantity, which means I've got to distribute that -1 through. So this is going to be 7 to the 6x minus 3x plus 15. And if I simplify that, I'm going to get 7 to the 3x plus 15. Okay, last example. We also need to be able to work these properties backwards. Okay, so it says use the second exponent property. The second property is x to the a to the b power equals, whoops, x to the a times b. Okay, to write each of the following in the form b to the x, where b is some positive rational number. So let's take a look at this. Okay, this is a little bit tricky. So it took me a minute. I had to reread this to think about it. So what I want is I want to change my base so that x is the only thing in the exponent. So I've got 3 to the 2x. Well, if I'm working backwards, I want to figure out what am I multiplying. So it looks like I'm multiplying 2 times x. So now how can I take multiplication and work backwards? Well, I'm going to keep it 3 to the second to the x power. And that's equivalent to this, which is equivalent to what I started with. And now I can say, well, what is 3 squared? Well, 3 squared is 3 times 3. So this is really 9 to the x power. So 9 to the x equals 3 to the 2x. Those are the exact same thing, just written in different ways. Let's take a look at part B. If I think about what I'm multiplying in my exponent, I've got 5 to the -1 times x. So now I want to rewrite this as 5 to some power to the x power. Well, that would be 5 to the -1. And 5 to the -1 means I'm really doing 1 over 5 to the first to the x power. So that's really 1 over 5 to the x. Okay, pause the video and see if you can do C and D. For C, I've got 2 to the 4 times x. So I can rewrite that as 2 to the 4th to the x power. And then I can put 2 to the 4th right in my calculator and I get 16. So it's 16 to the x. Next one is 10 to the -4 times x. So that would be 10 to the -4 to the x power. A negative exponent means 1 over 10 to the 4th to the x. And 10 to the 4th is a 1 followed by 4 zeros. So that's 1 over. So that would be 1 over 10,000 to the x power. And that's equivalent to what we started with. Just looks different. Okay. Exercise 8. We've got the expression 2 to the x over 8. So sometimes what we want to do is we need to rewrite the number as an exponential expression involving a smaller base. So how can I reduce this? So the first thing I want to think about is how can I rewrite 8 as 2 to a power? Well, 8 is 2 to the third. So now I can rewrite my original answer as 2 to the x over, and instead of 8, I'm going to replace it with what it's equal to, 2 to the third. And now I can rewrite this using subtraction in my exponent. So 2 to the x minus 3 power. Okay. Which of the following is equivalent to this? So go ahead and take a minute and see if you can figure exercise 9 out. So go ahead and pause. Okay. I want to think about how I can rewrite this. 25 is 5 squared times, this is just 5 to the x power. When you're multiplying, what can you do with your exponents? You can add them. So which of the following is equivalent? And I see 5 to the x plus 2. So that is the same thing. Okay. 125 to the x is a common incorrect answer. You can't multiply 25 by 5 because 5 is being raised to a power. So you have to be careful. Okay. Now you're going to need your whiteboard. And how this next part is going to work is I want you to write this problem on your whiteboard and we're going to solve it together. And then I'm going to give you some to try and you're going to pause the video, try to solve it, and then hit play and check your work. So make sure you've got this problem written down in your whiteboard and we're going to go ahead and solve it together. So we are multiplying here. When I'm multiplying, I need to add my exponents. Okay, but the -8 and the -5 are not exponents. Those are just being multiplied. So I'm going to multiply -8 by -5, and that gives me positive 40. Then I've got an x to the 5th times another x. Remember, that's x to the 1st. So I'm going to add my exponents, x to the 6th. And then inside the parentheses is a y squared. There's no y's out here, so it stays y squared. Now, if you've got questions on that, come up and see me. But if not, go ahead and erase that. And I'd like you to write this problem down, pause the video, and try to solve it. Then hit play, and you'll be able to check your answer. Here's the solution to this one. If you didn't get this, please come up and ask a question. But if you did and you understand it, then go ahead and erase your board. Here's the next problem. So go ahead and pause the video and try this one, and then hit play to check your work. Here's the answer. It's important to remember there's a 1 in front of here. So take a look at your answer, see how it compares. If you don't understand why yours is different or why this is the answer, come up and see me. Okay, here's a different one that we're going to do together. So again, on your whiteboard, I want you to go ahead and we're going to write this one down together. Okay. There's a 4 on the outside. So what that tells me is I'm going to have 4 6x to the 4th y to the 3rds. Now you can see where expanding is going to have its limitations. If this was raised to a power other than 4, like if it's the 9th power, you might not want to have to write that out 9 times. So let's see what patterns we notice. The first thing I want you to notice is this is a single term. There's no addition or subtraction in here. So if I'm taking a single item and raising it to the 4th power, that means I'm going to have 4 of each of these things that are inside. So the first thing I'm going to have is I'm going to have 4 6s, which is 6 to the 4th, times. The second factor is x to the 4th. So I'm going to have 4 of those, times. Then my y to the 3rd, there's going to be 4 of those. So what we did here was I took my first term, which was 6, and I raised that, sorry, not first term, my first factor, and I raised that to the 4th. Then I took my second factor, which was x to the 4th, and raised it to the 4th, because this 4 on the outside. Then I took my third factor, y to the 3rd, and raised it to the 4th. So you don't have to expand it out. Now, I'm going to go ahead and do 6 to the 4th in my calculator, and I get 1,296. Here, it's x to the 4th to the 4th. Well, it's a power to a power. So we multiply these. So it's x to the 16th. And then y to the 3rd to the 4th becomes y to the 12th. So there's my answer. So you can go ahead and erase the whiteboard. We're going to take a look at the next one. Here's the next one I'd like you to write down. And if you feel comfortable, you can go ahead and pause the video and try this one. If you want to see this one together, we can do this together. So this is one term, which means I can go ahead and square each factor on its own because I'm squaring the whole thing. So the first thing I've got is a 5, and I'm squaring it. The next thing I've got is an x, and I'm squaring it. And the next thing I have is a y squared, and I'm squaring it. 5 squared is 25. X to the first squared, remember we multiply, so that's x to the 2nd. And y squared squared would be y to the 4th. Okay, so there's your answer for that one. And there it is again, just in case you needed to see that. Okay, go ahead, take a minute, pause the video, and give this one a try. I'm going to go ahead and show you the first step right now. So hopefully you have that as your first step. If you don't, make sure that makes sense to you. And now try to simplify it and then hit play to check your work. And here is the answer. Okay. Here's the next problem. This is not exactly the same as the ones that we saw before. And the reason for this is we now have 2 terms inside. And when you have a polynomial raised to a power, when you have more than one term and you're squaring it, you have got to use an area model. With more than one term, you cannot distribute your exponent. Okay? So in this case, this really means 3x to the 3rd plus y squared times 3x to the 3rd plus y squared. And to multiply those together, I have to set up an area model. So 3 times 3 is 9. X to the third times x to the third. I'm adding my exponents. So that would be x to the 6th. Please remember there's a 1 in front of this y. 3 times 1 is 3. X to the third, y squared. I can't simplify that because this base and this base are not the same. Now I'm going to multiply this by this. Remember, there's a 1 there, so that's going to be 3. And I like to put my variables in alphabetical order, so it'll be x to the third, y squared. And my final step is this guy times this guy. 1 times 1 is 1. Y squared times y squared means I add the exponents, so it's y to the 4th. That should be a plus sign, by the way. It looks like multiplication. So does this one. That should be a plus. So now I can simplify by combining my like terms. My only like terms are here. So I'm going to write my answer. It's 9x to the 6th plus 6x to the third y squares plus 1y to the 4th. Okay. And again, the whole reason we had to do this is because there's more than one term in there. So I have to set up my area model. Go ahead and erase your board, and I'd like you to give this one a try. So pause the video and then hit play to check your work. Here comes the answer. So again, this is 2 terms. So I've got to set up an area model and multiply that out. Make sure you ask if you have questions. Go ahead and erase your board. Go ahead and write this one down. Make sure to analyze this one. I want you to think about how many terms are here. Since there's no addition or subtraction, this is 1 term. If it's 1 term, do I have to use an area model? I don't think so. So what we can do here is square each factor. So I'm going to do 3 squared times x to the 4th squared times y to the 5th squared. So go ahead and see if you can simplify that. And here comes your answer. Pause if you need. Let's look at another one. How would you do this one? So go ahead and pause. Write it on your whiteboard. Here comes the answer. Okay. If you didn't get this answer, please see if you can find your mistake. If not, come ask me. Okay, here's our next one. Okay, we're going to do this one together. So write this one on your whiteboard. What we're going to do here is we're going to simplify this, which means I need to figure out what 2 things I can multiply to get that fraction. And if I'm trying to simplify it, I'd like one of them to simplify down to 1. So if you're wondering what number can go into 125 and 25, here's a way you can figure that out in your calculator. If you go to menu and go to option 2, which is number, you'll see choice 5 is greatest common divisor. From there, you can enter the 2 numbers, 125. You've got to put a comma in between, and then 25. And if you hit enter, you can see 25 is the largest number that divides into both. So I'm going to put 25 up here and 25 down here. The top and the bottom both have x's. I want to take out the largest number they have in common. So that would be x to the 3rd. And then they both have y's. The largest number they have in common would be y squared. My next step is to figure out what I have to multiply this fraction by to get this numerator. So 25 times what number would give you 125? If you need, you can divide 125 by 25 and you'll see that it's 5. So if 5 goes here, I need to have 3 x's in the top. I already have 3 x's in the top, so I don't need any more. I need 5 y's in the top. I only have 2, so I need a y to the third. And that takes care of my numerator. My denominator has a 25 and it needs a 25. So 25 times 1. It's got 3 x's. It needs 4. So I need 1 more x here. It has 2 y's. It needs 2 y's. So it's done. So my answer is this simplifies down to 1. And my final simplified fraction is 5y to the third over 1x. Okay, erase your whiteboard. Here's the next one I want you to try. So again, we're reducing this. So I want you to see if you can figure out what you're going to simplify this into. So I'm going to have you pause the video, try to simplify it, and then hit play to check your work. Here's the first part that I'm going to have you check. Okay, so make sure that this is the first fraction that you pulled out. Go ahead and pause again and just double check that second fraction. Here comes the final answer. Okay, erase your board. Here's the next one. Same steps. See if you can figure out what fraction equal to 1 you're going to use. So pause, figure that out. Here's the first part. Now pause and see if you can find the second part. Here comes your answer. Okay, let's take a look at this. Okay, we're combining all these different rules. So go ahead and write this problem on your whiteboard. Since it's a big fraction, I need to simplify the top and the bottom separately. So my numerator is going to stay 2z to the 6th. My denominator, I have z squared squared. That's a power to a power, so I multiply those. The 2 is just by itself, so it stays 2. Z to the 2 times 2 is 4. And now I have to reduce this because I notice I've got things in the top and the bottom that are the same. So I'm going to rewrite this fraction. They both have a 2 in common. They both got z's. How many z's do they share between the top and the bottom? It would be z to the 4th. So now I've got to figure out, okay, 2z to the 4th times what would give me 2z to the 6th? Well, that would be 1z squared. And then 2z to the 4th in the bottom times what would give me 2z to the 4th? That would be 1. That reduces to 1, and 1 times z squared over 1 is just z squared over 1, or just z squared. Okay, so that's my answer for that one. Go ahead and write this one down and pause the video and see if you can work this one out. Here comes the first part. Now go ahead and reduce. So pause the video. Here's what you should have when you reduce it. Okay, so again, taking your time. And some of you may be reducing in a slightly different way, and that's okay. As long as your method is working consistently. Okay. Next one. Let me see on this one. Yes. Okay. So I want you to pause and give this one a try. Here's your first step. Okay. So it's one term. So I raised each power to the fifth. I want you to simplify the top now, just the top. Here's what you should have. And now you can go ahead and reduce. And here's what you should get. You could also reduce this by doing 243 over 3, which is 81. U to the 10th over U to the 4th, do 10 minus 4, which is 6. Okay, that's another way you could do it, but it's a little bit harder. It gets a little confusing when there might be negative exponents. So just be careful here. Erase your board. Here's the next one. Give this one a try. Here's your first step. Now simplify the top. So pause and simplify the top. Here's what you should get. Now go ahead and reduce. Here comes your final answer. Okay, so there it is. And that is it for this video. So you've got some practice and there's some review for your quiz. It is so, so important that you take your time with all of these properties. It is very easy to mix them up and get confused and go too fast. So be purposeful, take your time.